Everybody, welcome to the Institute for Catastrophic Loss Reduction's forecast webinar for the 2025 wildfire season. It is Thursday, June 12th, 2025. I'm your host, ICLR Chief Engineer, Dr. Keith Porter. I'm speaking to you from London, Ontario, traditional lands of the Anishinaabe, Haudenosaunee, Lenape, and Attawandaron nations. This is one in an annual wildfire forecast webinar series hosted by ICLR, Canada's leading source for disaster resilience knowledge. As in ICLR fire forecast webinars since around 2018, today's speaker is Richard Carr from Natural Resources Canada. Richard is one of Canada's most respected fire weather experts. He's a geographer by education. He has about 30 years experience in meteorological modeling, especially for wildfire meteorology. Fire agencies across Canada turn to him for fire risk forecasts, and that includes his own Canadian Forest Services Fire Group within Natural Resources Canada, the Canadian Interagency Forest Fire Centre, and federal emergency response agencies. To learn more about Richard's work, Google Canadian Wildland Fire Information System. Before our speaker begins, here's our agenda. Our webinar is going to last about 90 minutes. Our speaker will present for about half that time, then I'll moderate Q&A for the rest of the time. Please feel free to chat your questions into the Q&A box, not the chat box, but the Q&A box. I will try to pose your questions in the order they appear in the Q&A box. If we have a lot of questions, I may only pose your first question, then move on to others, then circle back to your additional questions. Our webinar is recorded. ICLR is going to post our speaker's slides and a link to the video on in the next day or so. So if you have colleagues who couldn't attend, let them know. They will find the slides and the video at www.iclr.org/workshops, where we put all of these and our Friday Forum webinar recordings. And I just wanted to let you know that tomorrow on June 13th, our friend Connell Miller from the Canadian Severe Storms Laboratory is going to tell us about the Northern Mesonet project. Connell's team is aggregating weather sensor data from multiple networks across Canada in a single user interface. If you or a colleague use weather data, tune in. I'm very excited about it because I'm a big data geek. So with that, I'm going to turn it over to Richard. Richard, welcome, and thanks for joining us today.
All right, thanks very much, Keith, for the introduction. Thanks, Paul, for the preliminary chat and getting everything set up here. So welcome, everybody. So I'm coming to you from Edmonton, Alberta. We're in Treaty 6 territory here in this part of Canada. So I think with that, we'll get off the title slide and start getting into some of the material. And as usual, I have to click into the presentation again before I can advance. So here we go. Just very briefly, kind of a schedule of what we'll go through here. We'll kind of compare the past few seasons, at least early season factors, and see what's similar, what's different. We'll look at our climate model predictions as usual, and the fire season forecast. So that was the last forecast that we issued was June 1st. We issue these on the first working day of each month from about March through September. So we're kind of basing this off the June 1st results. I'm going to first look at drought progression. So these are the end of May drought analyses, and these are done by Agriculture and Agri-Food Canada. The group in Regina puts these together, and the drought analyses go into a North American product as well that the US and Mexico contribute to. So what we're looking at is a Canadian drought monitor, but there's also a North American product that you can access from the United States side. Now, if you look at the end of May in 2023 at the top left there, we had fairly intense drought across parts of Western Canada. You see some pockets of red in southern Alberta. So that's getting into the extreme drought category. So, we're probably up around, probably 90% of the drought levels are below that. So we're getting into pretty extreme conditions in those red areas. And if you get into the D4, the exceptional drought, it's probably the top 2% of drought percentiles in the ranking system. So the end of May 2023, a fairly extensive drought through the west and also through parts of eastern Canada. We see fairly intense levels in the Atlantic region as well. Now, that progressed, drought intensified and spread across Canada during 2023. And the middle graphic here is the end of May 2024. So we're seeing pretty intense levels up in the northern part of BC, up in northwestern Alberta and southern Northwest Territories. And you can see a little bit of that patchy D4 level, the exceptional drought, just stretching across the Alberta-British Columbia border at that time. So um, we're up in the top 2% of drought ranking events. So pretty serious consequences when you get to that level. Now, a lot of people were fairly worried about 2024 just because the drought had continued to intensify through 2023 and through the winter of 23 and 24, but I think better spring precipitation in 2024, so it didn't really start with a bang like some people had worried about. But we still ended up with a pretty active year in 2024 with about 5 million hectares burned, so well above our long-term average of say 2.5 to 3 million. We look at this year, the end of May, and once again we're starting to see drought creep across the country. And earlier in the season, it didn't look too worrisome. We had fairly moderate drought levels across the country, fairly good snowpack in a lot of areas, maybe receding a bit more slowly than usual or maybe at a normal rate, so it wasn't too worrisome. But over the past few weeks, we've really seen drought intensify again, and we've got the epicenter setting in probably Saskatchewan or maybe draped across the Saskatchewan-Manitoba border. And we've got some of the big fires that are happening in the country right now coinciding with that area. Places like Flin Flon, Manitoba, Flin Flon and Creighton being on the Saskatchewan side, and then a bit further to the west, some big fires just around the Prince Albert area as well. So, we're starting to see those things happen where the drought levels are highest. And, I think we're maybe starting to see a few dribbles of precipitation starting to cross the prairies, but once again, it's probably not those big spring storms that we really need to dump a lot of rain and help out with the agricultural regions and maybe douse some of those fires. And we'll see what June brings, but right now it's not too promising, so we might see drought continue to intensify. I'm just going to step back a little bit this year. And, I've talked about this already, but if you look at the end of March on the left here, we did have kind of patchy drought here and there. Nothing too severe, but, we've had this long-standing area up in northwestern Alberta, northeastern British Columbia, and the Southern Territories. And it's still there. Some of that drought has been present since 2022, so fairly long-term drought, and that's what that little L in the middle of that brown region means is long-term drought. So it's been there for a long time. We've had fires that have smoldered through winters in those areas and popped up again in the spring, and that's happening again in that region. And we're also getting new fires in that area as well. But if you look at the end of May, well, that area has changed somewhat. I mean, we're not seeing quite as much of the severe drought in that region. That medium brown, I guess, just below the red category, it's shrunk a little bit, but we do see an expansion of the moderate drought, the lighter brown, and the yellow where it's abnormally dry. So it's covering a lot of the Northwest Territories now. I've seen a bit of improvement in southern British Columbia. It's a little chunk of southwestern Alberta that keeps kind of bubbling up and down there. It gets relieved a little bit from drought and then it intensifies again. So and probably an expansion, I guess, eastwards of all drought categories with that central Saskatchewan and extreme western Manitoba area that's the most severe at the moment. Interesting that this patch through the east from northern Ontario into Labrador is it's kind of intensified along that corridor there over the past month as well, and we haven't seen the heat that we I've seen in 2023 through northern Quebec in June, but it's still getting a little bit worrisome with increasing drought levels there. So we'll have to see what happens through that region as the year goes on. If we look at snow cover, this is just the past 3 years again, roughly the same dates. There's a little bit of variation, but not a huge amount. On the left there is 2023, so May 10th, we saw a lot of white showing up above that red line, which is the mean area where the 2 centimeter snow depth is still present for that particular day. So if you get that white above that red line, the snow cover has disappeared earlier than usual, and we see that through a lot of Quebec and Labrador as well in 2023. If there's color below that line, well, we've got snow cover lingering a bit longer than usual, and we saw that patch in 2023 just west of James Bay that had some fairly persistent snow cover in May in 2023. Now, sometimes in the spring, of course, you can get temporary snowfalls, and you'll get snow well south of that red line, but then it disappears again a few days later. 2024 is in the middle here, so May 8th, roughly the same date. The fairly normal recession of snow cover. There's little bits of variation along that red line, maybe Labrador, and I think had a bit of early snow loss and just other small pockets here and there. And on the right, May 14th from this year, it looks very normal again, fairly normal recession of snow cover, but I think with warm weather towards the end of May, we really lost snow in the territories quite rapidly and maybe parts of Quebec and Labrador, although there's still a little bit lingering in extreme northern regions there. But yeah, a fairly rapid transformation through May. Look at sea surface temperatures, SST as we like to abbreviate that. The red oval up on the top gives an indication of what the Pacific Decadal Oscillation might be doing. And one thing that we're seeing this year is, even though it's still negative, we've had a fairly broad span of negative indexes there. It's closer to neutral than it has been for the past few years. If we want a positive PDO, then we have the warmer water right along the Pacific coast and cooler water out in the middle, but we're still seeing a kind of cooler water along the Pacific coast and warmer water out in the central Pacific there. So still in a negative phase of the PDO, and it's quite broad. I don't really know the implications of that. It's probably a broader span than we've actually seen historically. So it's kind of an interesting period to go through. Below that, where we've got the rectangles, we've got the ENSO or El Nino Southern Oscillation regions, and the indexes for that are actually measured in the red box right there. And we see a lot of white inside that red box, just indicating a very neutral ENSO phase at the moment here. So just little patches where water is maybe colder than normal. The blue areas are maybe warmer than normal, where it's yellow or orange or red, but an awful lot of weight in that box right now. Now, even though some people were calling the past winter La Nina, I had doubts whether it actually reached a true La Nina. We had negative indexes, but we only had 1 month where it was below that half-a-degree threshold. And we really need a continuous 3-month period to qualify as a true La Nina or El Nino episode. So, just very borderline, very weak La Nina, if you can call it that. And so springs, El Nino Southern Oscillation springs, quite often favor fire activity in Alberta. It's really the province that has the highest spring activity in May usually, and a lot of that is driven by either an El Nino or a La Nina. The El Nino brings fairly warm, windy, dry winters and springs in Western Canada, and you can see some of the episodes historically had large area burned in 1995 and 1998 with El Nino springs. Then moving down the chart a little bit, 2016, of course, Fort McMurray. That was a very strong El Nino episode. So very light snow cover in the west, very warm temperatures through the spring in a lot of Western Canada, and of course we had those big fires in that part of the country that year. 2023 was a little different. It's kind of coming out of a long period of La Nina. We had a fairly extended period there covering about 3 years, and had a El Nino develop in the middle of the summer, which was a little unusual. It quite often doesn't happen that way. So 2023 was a different kind of beast. 2024, once again, we had an El Nino and kind of coming off that and fading into neutral during the summer, but once again, a fairly busy summer period, but maybe not so busy in the spring. With the La Nina, just the opposite, where you have those colder Central Pacific sea surface temperatures, tends to favor Arctic high pressure areas drifting in, which can bring very dry air. I know it might not always be cold in the latter part of the spring, but it is very dry with still a lot of ice over the Arctic Ocean and not much evaporation, not much moisture content in it. But once again, those surface Arctic highs can bring the very strong winds around the edges as they move through. So we quite often get big fire problems with La Nina events too. So see another extended period of La Nina in the latter part of the 1990s and early 2000s, and we had the Chisholm fire in 2001 in Alberta, which is a good example of that. Slave Lake in 2011, La Nina type year there, and maybe 2018 a little bit, but we really talk about the summer period, I think, in those years. And 2021 for sure, another La Nina year, and fairly active in Western Canada. Since I'm talking about La Nina here, I mean, we've had these extended periods of La Nina there in the latter 1990s, early 2000s, and once again, we've just come off one that kind of spanned the latter part of 2020 until 2022, and in both of those cases, and possibly in another episode, I think back in the 1970s or so, we've seen extreme drought problems following those extended La Nina periods. So it's maybe another interesting feature from those. We don't have a very big sample size to look at, but past 2 episodes, we've got pretty well documented drought in both of those cases following those extended La Nina periods. I guess in addition here, the orange shaded boxes that you see during the summer, those are big fire years in British Columbia, and they tend to favor fairly neutral conditions usually during the summer period. An exception might be in 2010 here with kind of a stronger La Nina carrying on through the summer there. But 2014, 2017, and 18, 2021 and 2024 all had neutral indexes and quite heightened fire activity in British Columbia. So with the Pacific Decadal Oscillation, this is ending in April this year. I kind of mentioned this before, but I just wanted to show you a graphic, and we've got that fairly broad blue patch just on the right-hand side of that chart. So fairly broad negative phase of the PDO, which is quite interesting. I think, I've had fairly active and extended periods before, but I think it's been a bit more consistent this time around. You see a lot of variation, I think, in earlier years. There was some thinking that maybe we're flipping to more of a positive phase in the mid-2010s there, but, quickly reverted again to negative. So I've been stuck in that negative phase for the past 5 years or so. Looking at the opposite side of the ocean, North Atlantic Oscillation out to May of this year, we've got the diagrams on the left-hand side here. So the positive phase features strengthening of the Iceland low and the Azores high, and that tends to favor dry conditions, at least through the winter and possibly in the spring in eastern North America. When you get those features weakening, then you tend to get wetter conditions farther north in the east and drier down through the south. But just looking through some area burned in Quebec. We've got the black years there where we have the most area burned. So 2002, I'll kind of step through from the beginning there, 2002, 2005, 2013, down on the next row, and then 2023, all had large area burned, and we might have those seem to happen when you get a transition or maybe kind of a weak North Atlantic oscillation. Maybe the exception to that is you start moving into the kind of the moderate area burn there, 2007 and 2010. Well, 2010, we've got that reasonably large area burned, but it's in a fairly broad negative phase of the North Atlantic oscillation. So it gives us another little quirk to try to figure out there. And then the green areas where we have very little area burned in Quebec, 2004 and 2008. And last one that we've got up here is 2015. So very small area burned in those years. And those seem to be happening in areas where we've got a fairly broad North Atlantic oscillation phase. So once again, not a huge number of years to look at there, but there's possibly some trends that can come out of that. There has been some work to look at kind of the western portion of this oscillation as well, and it's called the Baffin Island Western Atlantic Oscillation. And just looking at that western portion may help to explain big fire years in eastern Canada. You might have information on that as time goes on. Let's step into our current model predictions, and we'll look at the ENSO El Nino Southern Oscillation Forecast. And it's a pretty boring graph this time. The green arrow is pointing to where our recent forecast is from, so kind of the June forecast looking out. And if all of these plots from the different models kind of stay between those red lines, then we're in the neutral ENSO phase, and for the most part, they're all pretty much sticking to that neutral scenario. There's a few that are predicting more of a downward trend to a La Nina again, but not seeing any signs of that yet here. It's looking very neutral at the moment. Also have one or two that maybe point to an El Nino developing later in the year, but in any case, El Nino would be very weak if it actually happened. So really consensus, I think, is pointing to a neutral phase through the summer and into next winter. Just on the right-hand side, this time series ends in October of 2024, so a little bit behind. You just kind of see that negative phase starting to appear at that point in time, but not really getting into the La Nina territory. And if we continued this line, we'd just have a very brief dip, I think, below that lower black line, and then be back up again. So very neutral through the past few months. And looks like it'll continue that way for quite a long time here. And we have seen historical episodes where we have fairly long neutral periods, so not too much of a surprise there. I guess what's maybe surprising is just the amount of fire activity we've had this spring just with that neutral ENSO. Recent analog years. So 2012 is the orange year there, not a huge amount of area burned in that year, but these are all looking at just kind of neutral ENSO years. The black ones are fairly active years, 2017, 2013 and 14, and then I guess 2024 as well. What's interesting there is 2020, where we've had a very small area burned. I think it was probably the smallest in this period of records since about 1980 or so. Maybe 1978 was smaller, but very little area burned in neutral ENSO. And maybe part of that was due to COVID restrictions. Part of it, I think, was just due to fairly regular rainfall through a lot of the country. So yeah, maybe there's some consistency in some of those years, but still a lot of variation. I'm just looking at the models. CANSIPS means the Canadian seasonal to interannual prediction system. This has been developed and run by Environment and Climate Change Canada. So over the past year, they've increased the ensemble. So the ensemble is a group of similar models doing the same forecast, just with some slight variations, and might be variations in initial conditions or different physics packages, but they're all trying to forecast the same way, just with slight changes. And we can get an idea of the possible variation within the models system. So it's gone from 2 models, each with 10 elements, and they've been doubled recently. So we've got 20 members for each of those 2. So we're looking at 40 different forecasts for the season. Yeah, model names are listed here, CAN-CM4I or CAN-ESM5, and the GEM5 NEMO. The GEM is Global Environmental Multiscale. NEMO is Nucleus for European Modeling of the Ocean. So some variations in the models, and you can really see a lot of difference in the outputs between those 2. So that's one of the things that we wrestle with, is trying to incorporate results from both of these models that are giving different results into one forecast. We use temperature and precipitation data, plus our fuel moisture initialization from the Canadian Wildfire Information System. And I'll just mention that a little bit later in the presentation if it's not clear right now. The scale of the climate forecast is often best in the coastal areas, maybe not so good in mountain ranges. And part of the reason for that is the mountain ranges are maybe not explicitly defined in these models. It's more of a parameterization, and especially with large grid cells, we can't really model mountain ranges too well. Also, the closer we get, I guess, to our target dates, the more accurate the forecasts get, of course. And if we're looking at a summer forecast from March, may not be too accurate that far in advance. If you look at all the models that form the North American multi-model ensemble, the 2 Canadian models are inside the green box in the center line there. So the SM5 on the left and the GEM5 NEMO on the right. And look at temperature predictions here. So as I mentioned on the last slide, you can see a lot of difference in the 2 Canadian models. So in this case, the SM5 is predicting much warmer conditions through a lot of Western Canada. GEM5 NEMO tends to predict warm, but not to as great as an extent, and focuses the warmth a bit more in the east. Now with all the other models here, we've got a very variety of American models as well, and that all goes into forming the North American multi-model ensemble. So that's kind of the consensus at the top left. At the bottom right, the IMME is an international equivalent, uses some European models as well to form a consensus of those models there. So you're going to see similarities or differences. The North American one tends to produce a greater extent of warm forecasts across the country. European model, somewhat similar, but doesn't extend that quite as far north or south as the North American one does. Now, these quite often look dramatic, but you have to subtract a little bit in this calibrated forecast, and the top right maybe gives a truer picture of how warm conditions may be compared to a normal, and what the extent might be. So once again, that focuses most of the warmth in the eastern half of the country, probably from Manitoba eastwards. Other patches will be probably warmer than normal, but maybe not quite as consistent. And sorry about that. Didn't animate the box there. There's a precipitation outlook. Same kind of scenario here. We've got the Canadian models in the green boxes in the center row, and the other American models scattered about. International ensemble at the bottom right, North American ensemble at the top left. So, both Canadian models are predicting a fair amount of dry countryside throughout the summer. I guess I didn't mention this. This is the July, August, September outlook here. So summer period, not including June in this one, but just the summer 3-month period here. Yeah, a lot of dry regions, and a lot of the other models are predicting fairly similar conditions. The one exception, maybe the NCAR model down in the bottom row here, which looks like there's maybe not too much signal across a lot of the prairies, or maybe a slightly wet signal in parts of Alberta and Saskatchewan, but still a lot of dry in the east. The NASA model here is predicting more moisture in the east, so precipitation being harder to forecast does often show a lot more variety than temperatures. But the consensus still features a fair amount of dry countryside through a lot of the country, and it seems to be focused probably in the west or central regions. Even though the east may be warm, maybe there's adequate precipitation out there that helps prevent too many fire problems. Now we take our results from the Canadian models and put it into our NRCan seasonal prediction. And I've mentioned the field moisture codes before, so if anybody hasn't seen the Canadian Forest Fire Weather Index System schematic, this is it. They've got, at the current time, noon temperature, relative humidity, wind speed, and rain that go into the calculation of these indexes. And the field moisture codes are across the top row here. As we go deeper into the organic material in the surface, we tend to lose the effects of some of those. So with the DMC, we lose the effect of wind. If we go down deeper, say below about 7 centimeters or so, then the drought code loses the effect of relative humidity. But we run these year round, so our seasonal forecast uses these field moisture code values to help initialize the fire weather index calculations that we perform on each of these model ensemble elements. So we calculate all of these indexes, and most people are probably familiar with maybe the FWI, the fire weather index at the bottom, and especially the fire danger, which goes into the positioning of the signs that you quite often see in forested areas. Maybe not so familiar is what comes out of the right-hand side of the box here. And the FWI itself doesn't lend itself to statistical analysis very well, but we can linearize that FWI and come up with a daily severity rating. So just a simple exponential relationship from the FWI to come out with a DSR, or daily severity rating. So we can sum all of those values up and come out with a monthly value, and that's what we're actually comparing here in the seasonal forecast is the forecast monthly severity rating versus the historical 30-year hindcast. If you actually carry that further, you can actually look at the entire season and come up with the SSR, or seasonal severity rating, but we don't actually use that in our forecast. We're just looking at the monthly periods and comparing the forecast month with the equivalent historical month. So here's what we've got. Won't be looking at June since we're already partway through that. It's June run, but we'll look at the July to September forecast. And July on the top left here, pretty brightly lit up from the western half of the country. And if you look at the earlier forecast, well, May looked a lot like this as well, with indication of possible above normal severity through a lot of Western Canada. I think in the May forecast, maybe we kind of got a false positive there in southern BC. Not too much has happened in the south, but it's been more active in the north. And also from the May forecast, well, we had that southwest corner of Nunavut and the Eastern Territories indicated as having a higher than normal potential as well, but there's still snow cover in that area. So nothing really happened except very late in May, I think, with that heat coming in. We got the snow melted off there pretty quickly, but it was too late in the month to have anything happen up in that region. But, now the snow is gone. Well, there's potential, I guess, through July. And tending to see that increase to well above average through a lot of that region in August, that center map there. So we've got a lot of that area lit up in the bright red right from British Columbia up through at least the southern and central Northwest Territories, and then eastwards to the Manitoba-Ontario border. In September, still fairly brightly lit up there, a lot of much above average through a lot of the west, and potential for above average, kind of the pinkish color there as well. One thing that does happen, though, by the time you get into September, well, we're probably starting to see conditions cool off in at least northern part of the territories. The nights become cooler, and if you have any moisture, it tends to retain it better, so we don't get that early morning evaporation that can lead to fairly high fire, heightened fire activity during the day. So it takes a bit longer to get going, but any big fires up in that region, of course, can keep smoldering. Also, another thing to keep in mind, of course, is even though we have colors, in the agriculture and grasslands region there, it's maybe not something to worry about early in the summer, but if it's dry, by the time you get to August or September, maybe those grasses and other crops are starting to dry out enough that you could get fire in those again. It's not something that we'd really expect through, say, mid-May through July or so, but maybe August, especially later August and beyond, maybe that grassland fire danger increases again. The current season snapshot, well, we've got the big fires from Western Ontario right through northeastern BC and kind of a few scattered smaller ones here and there. Biggest fires concentrated in that drought area through central Saskatchewan and west central Manitoba. Certainly have had some big and active ones in Alberta and northeastern BC as well. A little bit just creeping into the southern parts of the Northwest Territories, but not too widespread up there yet. And the biggest ones, the central Saskatchewan, maybe 650,000 hectares or bigger. That's a merger of a couple of fires, which is just going by the name Shoe Fire at the moment, and Flin Flon, Manitoba, Creighton, Saskatchewan, another similar event where we've got merged fires that are probably 500,000 hectares or larger. A lot of other ones are probably in that 50,000 hectares or larger size, and numerous smaller ones as well. So, we kind of shot past our average annual area burned already through early June. So that late May to early June period, we really saw a lot of active growth. A lot of that was driven by wind. It's been a very windy spring. Talk about that a little bit later, so maybe I won't say too much right at this moment here. So should go into the next slide to do that. And I've got an example from June 4th on the map showing a lot of hotspots, so a lot of wind-driven growth at that period. We do not have wind comparisons with normals at the moment, but we've discussed the need for that. And, I think in a year like this, it's important to include wind comparisons. Since I'm mentioning that, our seasonal forecast does not include wind speed, just temperature and precipitation in the forecast. So I think in the future we will include wind data, and we're working on a different product that will kind of supersede our current forecast process. So more on that later. As I mentioned, the current burned area, last time I looked, it's about 3.3 million hectares. We surpassed our annual average, which is somewhere in that probably 2.5 to 3 million hectare range. I passed that by about June 7th or so. I should correct myself. I've got the 3.5 million hectares updated as of yesterday in that fourth bullet down there. So, yeah, 3.5 million and growing. CIFC National Preparedness Level has been at level 5 since May 29th, level 3 since mid-May. That's the scale just below that, and the colors. We start the season off usually in blue where not too much is happening. Level 2 in green, we're starting to see some fire activity. By the time we get to the middle of the scale at level 3 or higher, we're starting to see active fire in more than one jurisdiction, one province or territory. Probably 2 or 3 are experiencing heightened fire activity, and at that point, we start looking out into the 2 to 4 week forecast period to see if there's going to be a need to bring in international crews or other types of resources. This year we're going to skip by level 4. I think we stayed there for a day or two and then jumped to the highest ranking on that scale, level 5, and we've been there since May 29th. And at that level 5, our Canadian fire suppression resources are probably tapped out, and we're definitely bringing in crews from other parts of the world. So we've got people from USA and Australia right now, and are looking at Costa Rica maybe to bring in resources from that country in the next few days. Some of this information you can get from our Canadian Wildland Fire Information System interactive map. There's the URL on there. We've got drop-down date menus at the top, so you can switch the dates there. You can go back and forth with the previous or next day, or back to the current day with those buttons there. If you do click on a feature, in this case, I've got the top right corner of the box pointed to this fire in eastern Manitoba. So you click on one of those features and you'll get some associated data popping up in this box here. So at that particular point, that fire is at about 63,000 hectares and showing rapid growth. Down below here is all the hotspots associated with that. So you get quite a list of information there. More buttons, there's the overlay button here, so people can choose different overlays. And once again, if you bring those up, you can click on those and get different types of information popping up in those boxes. So where do you find the monthly forecast? Well, we do have the monthly and seasonal forecast just in the left-hand panel of the CWFIS. So you can look at these products month by month. It doesn't show them all at once, but you have to choose the month and retrieve the map for it. This is the way it stands at the moment here. We do have a team that's working on an update to the website, and we're probably be doing an internal rollout this year, and it'll probably be brought out to the public either late in 2025 or maybe in early 2026. So there's going to be a lot of added features. The information will look different. It's going to be arranged differently. And the interactive map, I know for one thing, will have a much larger variety of information available to the user. So yeah, I look forward to rolling that out and maybe updating people on it as that occurs. All right, a few conclusions and reminders. Looks like a pretty warm summer again coming up, and it seems to be consistent, and maybe that's a common thing with a warming climate. If you're comparing a forecast for one summer with a 30-year period, well, if you have a warming climate, maybe all summers look warmer than usual, and you can still have cool periods, but they seem to be less frequent, maybe cover less territory and less prolonged than we've seen historically. Looking at potential dry conditions again, especially from southern BC to the central part of the country and maybe some parts of the east as well. And we're seeing that strip of drought intensify from northern Ontario through central Quebec and Labrador. So it's an area to keep watching through there. Neutral El Nino Southern Oscillation Index. Well, we've seen a number of years with higher activity in Western Canada, and maybe we'll see that again. But with the activity that we've seen so far, it's there's a lot of question marks, I think, as well. What's driving that? We've certainly seen Arctic air kind of dominate central Canada through the spring, and that's maybe typical of a La Nina type event. And we had that kind of negative ENSO through the winter and early spring, and still continuing, but very weak, very close to neutral right now. So maybe there was a bit of a La Nina type driver early this year, maybe contributing to dry conditions through that part of the country. Just always remind people that we can get serious fires through any year. It just depends where the ignition is and how close it is to people's homes or other types of communities or infrastructure. Fire activity really depends on the ignitions. The forecast only highlights where the potential exists, but if you have maybe less human activity or more careful human activity, there may be less ignitions. Sometimes you get these large high pressure areas that really suppress convection, so you don't get much lightning for weeks sometimes, and that will affect ignitions as well. Just a couple of shout outs to team members here. So we've had Robert Jagosinski kind of clean up our code a little bit and move it over to our Azure system. So that's where it's been run from this spring. And Piyush Jain is working on a new methodology, which he's kind of in the preliminary stages right now, just kind of doing a bit of testing, but maybe later this year that will be rolled out as well. And probably won't be in time to actually produce a forecast with it for this year, but we should be able to use that new methodology in 2026. So maybe that's something else too that can be rolled out to a broader audience sometime later in the year. Just a reminder, first working day of each month, seasonal forecasts are posted March through September, and daily conditions can be monitored at any of the provincial websites or the Canadian Wildland Fire Information System website. So just thanks to all the provinces and territories. As you can see, their logos below there. And that will bring me to the questions or discussion page. So, once again, I'll turn it over to our moderators to help with any questions.
Thank you so much, Richard. Another great talk. I always feel we're in such good hands when you speak. I have a question. I have several questions,
certainly.
but I'm gonna give you one of mine, and then Paul has a question. Going back to slide 19, you talked about it talks about the NRCan CFS prediction. It predicts above average July to September, with August being well above average. Does that account for climate change? Is that well above average for what we would expect right now, given the state of the climate, or is that compared with the last 30 years, or what does that mean?
Yeah, that's really compared with the last 30 years. But once you get into that well above average category, so I think, you're probably expecting a fairly heightened activity, even compared to the past few years, I think. So, we're kind of seeing possible conditions that would be similar to the past 2 years. We've had active summers both in 2023 and 2024. So, once again, it's kind of looking like that may be the case again. And right now in June, like a forecast didn't really highlight many areas for June. And it's really the month where we get the bulk of the precipitation in Western Canada. And the question is, whether you get enough through June. And I think we're kind of heading into a slightly wetter period through the middle part of the month. But once again, if that starts to dry out in July, then we don't get enough June precipitation. It kind of sets the stage for a fairly active July and August again. And especially in late summer, as they tend to get those precipitation levels starting to taper off again. So yeah, maybe the July map isn't kind of lit up as much as August, just because any precipitation that we get through June or early July may tend to keep things a little bit quieter. But it looks like with extended warmth and maybe dryness through the latter part of July and into August and September, we tend to get those elevated levels again.
I was sort of getting at the highest level interpretation of that question. I mean, can we sort of expect, given the state of the climate and sort of the direction of climate change, can we expect above average and well above average to be more normal for the next few years?
Yeah, I think it'd be something that you see more commonly for sure.
Awesome. Okay, thanks. Yeah. Our executive director, Paul Kovacs, asks, 2023 was an extraordinary year for area burned in Canada. Would you kindly reflect on why that season was so unusual and the chances for something like that happening again?
Yeah, I think, first of all, with the huge amount of area burned, I think our official numbers were somewhere around that 15 to 16 million hectare total. It's really quite an outlier. The previous record was, about half that, I think. So somewhere around that 7 or 8 million hectare mark. So quite an outlier. There's probably a number of factors that go into that, and maybe some that we, haven't fully explained. But we did have some unusual weather features that year, and when things were starting to become very active right across the country in June, we had an upper ridge of high pressure that, first of all, transited west to east as it usually does. Then it retrogressed, actually moved westwards again, so it moved west from Quebec right across the country into Western Canada, and then it got forced eastwards again for the second time. So it actually traversed the country 3 times during that month, which was really unusual. And you don't really know what the cause of that type of persistent feature would be. We did have the El Nino develop through the middle of the year, which was kind of an unusual event. We had record warmth in the oceans, I think, through a lot of that year. Just about all of the oceans were showing above normal temperatures, and that might have driven that to a certain extent as well. But I think there's a lot of questions that we don't really have a solid answer to.
Mhm.
Of course, with climate warming as well, if you throw in these factors and climate warming, you can probably come out with a fairly catastrophic year. 2024, with 5 million hectares burned, was still very active, and probably in the kind of the upper part of the area burned totals that we've seen over the past 10 or 20 years. But still, it has happened before as well, so you probably got those years that maybe show those fairly large area burn totals. This year we're probably going to have a fairly big total as well, with above our annual average already, and some active fires going for sure, and probably heightened activity through the summer. The question is how big it'll come out to be.
Okay. Let's see. Let me ask one of my questions before I come back to Paul.
Okay.
The Canadian Wildfire Information System is a wonderful, rich resource, but there's a lot there. Maybe it's a little bit overwhelming for people who are just looking at it for the first time today. Can you suggest one or two of the most popular uses? Where do you think viewers like our attendees today, who are total newcomers, are going to get the most value, maybe on a day-to-day or at the beginning of the season basis?
Yeah, that's a pretty good question. I think the most popular page is the interactive map. We can overlay the daily fire danger on that at the current time. So you can get a good idea day to day of what conditions are looking like. You can get that fire danger on there, the hot spots where we get thermal detections from satellites where the fires are burning. You can put up the fire points from provinces and territories, and you click on those, you can get an idea of the fire size. So there's a fair amount of information there. And we also create polygons from those hotspots, so you can get a rough estimate of what area is burned from each of those fires as well. So I think it's a very popular tool. You can zoom in and pan around. So just a word of caution with that, though. If you zoom in too far, then some of those overlays may show a bit of inaccuracy in them. We get things like roads that travel up rivers, for example. So if you zoom in too far, it's maybe a bit detrimental in ways. But still, if you zoom in the right amount, you can get a lot of information, and it's all in one place.
Cool.
When we release the new website, we'll also have all of the other Canadian Forest Fire Weather Index System, or Fire Danger Rating System themes available to put up on that map. So
Awesome. I'm looking forward to it.
certainly.
Paul asks, wildfire risk in British Columbia and Alberta appear to be driven by different factors than those in Eastern North America. Is wildfire risk in Saskatchewan, Manitoba largely driven by the factors affecting BC and Alberta, or is the risk in Saskatchewan and Manitoba distinct?
Yeah, that's a good question too, and an interesting one. I think for Western Saskatchewan, it quite often may, in fact, maybe a larger part of Saskatchewan, may react the same way as Alberta does in the spring, at least. We can get those fairly volatile spring conditions right from northeastern British Columbia through Alberta and into at least part of Saskatchewan. Once you get to Manitoba, though, it's there's maybe different influences, and it's kind of an interesting position there, right in the middle of the country, and a lot of land on each side, and Hudson Bay to the northeast. So yeah, different influences possibly in Manitoba, and we've had a fairly active fire in Western Canada and Eastern Canada, and then Manitoba sometimes gets a funnel of moisture up from the US, for example, and not much happens there. So it's probably subject to different influences, I would think. And
Okay.
yeah, it's maybe something that we haven't really looked at enough.
It's its own region, distinct from the
It
east and the west.
yeah, it could, yeah, Manitoba, Western Ontario. Once you get further east in Ontario, once you get east to the east side of the Great Lakes, well, the annual precipitation levels increase quite a bit through that region. So, um, in most years, you probably don't get too much activity through eastern Ontario and into Quebec with those higher precipitation levels, but still you get those years where Quebec can be quite active, and you seem to see those every 10 years or so. 2013 was another example, and maybe 2003.
Okay. Another question from Paul about the LA wildfires in January. The wildfires in Los Angeles earlier this year were remarkable in terms of destruction of property. Were the wildfires in LA unusual in terms of fire risk or behavior?
Yeah, it's a question I probably can't answer fully just because I didn't really focus too much on what happened down there and the causes. What I do find a bit unusual is the fact they happened in January. California, Southern California especially, can have fairly big fiery events, usually late in the autumn, um, late October, November, maybe early December. And quite often what drives those is cold Arctic air sinking down through the Western Canada. So, if we get an early onset to winter, we get that cold Arctic air coming down and forcing its way into the Western US, and that's what drives those Santa Ana winds across the mountains there. And it's like the reverse of the Chinook in Western Canada. You get that dry air passing over the mountains from east to west down towards the Pacific coast, and it compresses and warms, and it's windy. It's very dry to begin with, and you lose more moisture crossing the Sierra Nevada, for example, and other mountain ranges down there. So you often get those events happening in maybe late October, November, and early December that quite often drives the big fires in Southern California. So maybe a bit more unusual to have it in January, where there might be a bit more Pacific moisture that gets forced onto the coastal areas down there. So yeah, interesting event, and I'm sorry I don't really have a complete answer for that.
But that was definitely Santa Ana's. The winds were from the north and slightly east at the time,
Yes.
as I recall. Um, let's see. We just have, sorry, I said 90 minutes as if this were a Friday forum. This is a 60-minute webinar, so apologies about that. We just have a couple of minutes left.
Right.
I am going to I'm going to ask you any last piece of advice or information you want to leave us with before we wrap up today's conversation.
Well, I just one thing that I'm probably happy about is we do have a bigger team, a fire team in Natural Resources Canada, and we're probably in a better position to try to tackle some of these questions that we don't have good answers for, and improving our forecast methodology as well. So, I think it's a really important step forward. And I have to admit, I've got my fingers in too many pots and can't devote enough attention to each of those. So having extra help, I think, is extremely important, and that'll maybe help bring about better products or better analyses in the future.
That's exciting. Looking forward to it. Richard Carr, thank you so much for another awesome forecast webinar. Very grateful for your presentation every year. I want to thank everybody else for attending and remind you that if you have time tomorrow and you're interested in weather data, join us for our Friday forum. Once again, that's Conor Miller from the Canadian Severe Storms Lab. He's going to tell us about the Northern Mesonet project. As a reminder, you'll be able to find Richard's slides and a video of today's talk and a transcript of today's talk at our usual place where we store these videos, www.iclr.org/workshops. Thanks, everybody. Thanks for coming today, and I hope to see you tomorrow or in a future webinar. Bye-bye.
Right. Thanks very much, Keith and Paul, and thanks everybody for attending.
Oh, and thank you, Paul, for handling the technology today.